Dear students, welcome to the program. Today we are going to discuss another important topic on mushroom cultivation technology. And our today's topic is entitled as Optimizing Growth Conditions for Speciality Mushrooms. Let's have a look on today's objectives. Our first objective will be to have a brief introduction on growth conditions required for specialty mushroom production. Our second objective will be to have a general discussion on the dynamics of specialty mushroom production in India. Our third objective will be to discuss in detail the optimization of growth conditions for shiitake, enoki and maitake mushroom species. And finally, we'll be having concluding remarks on today's discussion. Let's begin our topic with introduction. Mushroom farming created a revived opportunity in indoor agriculture and attracted unemployed youth and new generation farmers to venture into its production across the country. Undoubtedly, mushrooms are a high-value agriculture crop with the potential to augment the income of small and marginal farmers. Mushroom cultivation is a strong means to diversify and strengthen the resilience of farmers. There has been a significant increase in the production of mushrooms in the last few years, especially of the white button and paddy stalk mushrooms in India. However, despite proven therapeutic and nutraceutical benefits, the production of specialty and medicinal mushrooms is not increasing in India. However, China's contribution to global mushroom production has significantly increased in the last 3 decades. The major share in this comes from the specialty mushrooms such as shiitake mushroom, winter mushroom, king oyster mushroom, white jelly mushroom, etc. Optimizing growth conditions for specialty mushrooms is both an art and a science, a multifaceted endeavor that involves replicating the delicate shades of each mushroom's natural habitat while leveraging modern technology to maximize yield, quality, and consistency. Specialty mushrooms such as shiitake, maitake, enoki, lion's mane, and others have unique physiological and ecological requirements that directly influence their flavor, texture, and medicinal properties. By tailoring the environment to meet these specific needs, cultivators can produce mushrooms that not only satisfy culinary and health demands, but also support sustainable production practices. Environmental parameters play an equally critical role. Temperature, humidity, and light are interdependent factors that must be managed throughout the various stages of the mushroom life cycle, from spore germination and mycelial colonization to primordia induction and fruiting. For example, many specialty mushrooms thrive in cool, humid conditions during fruiting, often between 50 to 65 degrees Fahrenheit with high relative humidity, while their incubation phases may require warmer temperatures to promote vigorous mycelial growth. In some cases, like with enoki mushrooms, minimal light exposure is necessary to achieve their signature elongated white stems, whereas other species may require specific light cues to trigger fruiting. Advanced monitoring systems, including digital sensors and automated climate control technologies, allow growers to continuously track and adjust these conditions in real time. Such precision not only enhances productivity, but also minimizes risks related to contamination and environmental fluctuations. Moreover, understanding the delicate balance of carbon dioxide levels and fresh air exchange is crucial, as these factors significantly impact mushroom morphology and overall yield. In essence, optimizing the growth conditions for specialty mushrooms involves a holistic approach, starting with a well-prepared substrate, followed by meticulous environmental management and supported by technology that ensures consistency and sustainability throughout the cultivation process. This comprehensive strategy transforms mushroom farming into a reliable and innovative agribusiness capable of meeting both consumer demands and environmental challenges. The successful cultivation of specialty mushrooms such as shiitake, enoki, maitake, and others requires a deep understanding of their specific growth requirements and precise control of environmental conditions. Each mushroom species has unique needs, but there are common factors critical to optimizing their growth. Dear students, let's now talk about the dynamics of specialty mushroom production in India. Mushroom cultivation in India started in the 1960s with button mushroom known as Agaricus bisporus production in regions such as Himachal Pradesh and later expanded during the 1970s and 80s. The research and technology dissemination by institutions like Directorate of Mushroom Research has significantly increased production over the decades. Over the last 35 years, overall mushroom production in India has increased substantially from modest initial yields to record production levels. For example, reaching up to 2.25 lakh metric tons by the year 2020-21 with an average growth rate of around 4.3% per annum. Although white button mushrooms dominate the market, specialty mushrooms including shiitake, maitake, oyster, milky and medicinal varieties are emerging as niche products with high nutritional and therapeutic value. The mushroom industry in India is characterized by a mix of large-scale commercial operations and smallholder farmers. While button mushroom production is well established, specialty mushroom markets are still emerging with significant export and domestic growth potential. Rising income levels and urbanization are expected to boost demand, while improved packaging and extended shelf life through technology, for example, controlled atmosphere packaging, help maintain quality. However, challenges include limited standardization, infrastructure gaps, high production costs for specialty varieties, and competition from imports. States such as Himachal Pradesh, Punjab, Odisha, Maharashtra, Tamil Nadu, and the northeastern region are leading producers. For example, Solan district in Himachal Pradesh is often referred to as the mushroom city of India due to its high production and research presence. Several innovative farmers and entrepreneurs, including women leaders like Beena Devi, known as the Mushroom Mahila, have driven grassroots adoption of mushroom cultivation, promoting both food security and income diversification. Award-winning business and cooperative models are increasingly contributing to specialty mushroom production, leveraging both traditional knowledge and modern technology. The dynamics of specialty mushroom production in India reveal a sector with substantial growth potential driven by improved cultivation practices, rising consumer health awareness, and innovative entrepreneurial efforts. However, to fully capitalize on these opportunities, addressing technical, infrastructural, and market challenges through coordinated research, policy, intervention, and capacity building is essential. With sustained focus and strategic investments, specialty mushrooms could not only enhance nutritional security but also become a significant driver of rural income and sustainable agriculture in India. Dear students, let's now discuss about the optimizing growth conditions for specialty mushrooms. Optimizing growth conditions for specialty mushrooms involves altering the environmental parameters and substrate composition to meet the specific requirements of the mushroom species being cultivated. Let's discuss some of the important specialty mushrooms and their optimized growth conditions as follows. First, we talk about the optimized growth conditions for shiitake mushrooms. Optimizing growth conditions for shiitake mushrooms is an intricate process that requires balancing a host of variables from substrate composition and spawn inoculation to fine-tuning temperature, humidity, and air exchange. By closely mimicking the natural hardwood forest environment where shiitakes thrive, while leveraging modern techniques for substrate sterilization and environmental control, growers can achieve robust mycelial growth and consistent high-quality mushroom yields. Whether cultivating on logs or using sawdust blocks, regular monitoring and incremental adjustments are key to successful shiitake mushroom production. Let's discuss in detail the optimum conditions required for the growth of shiitake mushrooms as follows. First, let's understand the natural habitat, ecology and origin. Shiitake mushrooms naturally colonize hardwood forests, especially oak, maple, and elder. In the wild, they grow on decaying hardwood logs where moisture, temperature, and nutrient availability are finely balanced. Let's talk about its key traits. Lentinula idodes produces robust, flavorful fruit bodies with a leathery cap and dense texture. Their growth is influenced by seasonal temperature variations and high humidity under a forest canopy. Substrate selection and preparation. First, we discuss the substrate type, in which we are going to discuss hardwood logs first. Traditional shiitake cultivation often uses freshly harvested oak logs or other suitable hardwoods such as maple or elder that retain bark for moisture control. Second is the sawdust blocks. Commercial operations and indoor growers often use sterilized hardwood sawdust supplemented with bran, which include wheat, rice, or other cereals to enhance nutrient content. Let's talk about the moisture and nutrient balance. First, the moisture content. The substrate should have moisture level of about 57 to 65%. A good test is to squeeze a handful and observe a few drops of water. Let's discuss about its supplementation. When using sawdust substrates, adding 20 to 35% bran or other nutrient supplements can boost mycelial growth and subsequent fruiting. Let's discuss about its sterilization or pasteurization procedures. For sawdust substrates, sterilize by autoclaving typically at 121 degrees Celsius for 1 to 2 hours or pasteurize at lower temperatures around 65 to 70 degrees Celsius for 2 to 3 hours to reduce competing organisms. For logs, pre-treatment via steaming, boiling or pressure cooking, may be used to reduce contamination while preserving the log's natural nutrient profile. Third is the spawn selection and inoculation techniques. Let's talk about the spawn options. First, we have plug spawn. Commonly used for log inoculation, pre-colonized wooden dowels plug spawn are inserted into drilled holes along the log. Sawdust spawn, often mixed into sawdust substrates for bag cultivation, ensure even distribution at an inoculation rate of approximately 5 to 10% by weight. Let's now talk about the inoculation process. First is the log inoculation. Drill holes approximately 1.25 to 1.5 inches deep in a diamond or staggered pattern to maximize surface area. Insert plug spawn into each hole and seal with melted wax, preferably paraffin or cheese wax, to maintain moisture and prevent contamination. Let's talk about the sawdust block inoculation. Mix the cooled sterilized substrate thoroughly with the spawn in a clean environment. Pack the mixture into autoclavable bags or blocks with breathable filters to allow for gas exchange during incubation. Now, dear students, let's talk about the optimized growth conditions for enoki mushrooms. Optimizing the growth conditions for enoki mushrooms, known as Flammulina velutypes, requires precise environmental control to achieve their characteristic long stems, small caps, and crisp texture. Key factors include selecting nutrient-rich substrate such as hardwood sawdust with supplements, maintaining sterilized conditions to prevent contamination, and carefully managing temperature, humidity, light, and carbon dioxide levels. By carefully controlling these parameters, growers can maximize enoki mushroom yield, texture, and quality, ensuring a profitable and efficient cultivation process. Let's discuss in detail the optimum conditions required for the growth of enoki mushrooms as follows. First, we understand the enoki mushroom's biology and appearance. Enoki mushrooms are characterized by long, thin, white stems with small caps. In their cultivated form, they are grown under conditions that promote stem elongation and minimal cap expansion. In contrast, wild enokis tend to have shorter, stouter stems and browner caps. Now let's talk about its natural habitat. In nature, enoki, often called enoki teak, grows on decaying hardwoods in cool, damp environments. Mimicking these conditions in cultivation is critical for achieving the desired morphology. Second is the substrate selection and preparation. First, what are the suitable substrates? Sawdust or hardwood chips. Enoki mushrooms are often grown on sterilized hardwood, sawdust, or a mixture of sawdust and straw. Many commercial growers enrich the sawdust, often from hardwoods, with supplements such as rice bran or wheat bran. These supplements provide additional nutrients and help support vigorous mycelial growth. Let's talk about the moisture content. A proper moisture level, typically around 60 to 70%, is essential. Too little moisture will slow mycelial colonization, while too much may encourage contamination. Uniform moisture distribution is key during substrate mixing and packing. Let's now talk about the sterilization and pasteurization. The substrate must be sterilized typically by pressure cooking at 121 degrees Celsius, which is around 250 degrees Fahrenheit, for 90 to 120 minutes to minimize contamination from competing microorganisms. Let's now talk about the spawn and inoculation. First, let's talk about spawn type. sawdust span or grain span. Both are common. They must be evenly mixed into the sterilized substrate under aseptic conditions. Inoculation process. Mix the span thoroughly into the cooled substrate in a clean environment using sterile tools and gloves to ensure uniform colonization. Transfer the inoculated substrate into appropriate containers such as glass bottles, jars, or grow bags that will allow you to control the microenvironment. Let's now talk about the transition to fruiting conditions. Enoki mushrooms require a marked change in environmental conditions to shift from mycelial colonization to fruiting. Let's now talk about the temperature drop. First is the pinning trigger. A cold shock or significant temperature drop is critical. Pinning is often induced by lowering the temperature to between 7 degrees centigrade to 10 degrees centigrade. Fruiting phase. Once pins appear, the optimal fruiting temperature is maintained between 10 degrees centigrade and 16 degrees centigrade. Let's talk about the humidity control. During pinning, very high humidity, around 95 to 100% is required. Once fruiting, slightly lower but still high humidity, around 85 to 95% is optimal. Let's now talk about the light conditions for the growth of enoki mushrooms. Enoki mushrooms are typically grown in darkness or very low light. This limited light exposure is key to producing the long, white and noodle-like stems. Even a slight exposure can sometimes induce browning in the caps. Let's now talk about the ventilation and carbon dioxide. For fruiting, improved air exchange, fresh air is needed to reduce carbon dioxide levels. Lower carbon dioxide helps in proper cap formation and prevents over-elongation solely by carbon dioxide influence. Some growers purposefully maintain a higher carbon dioxide environment during incubation and then gradually introduce fresh air during fruiting. Dear students, let's now talk about the optimized growth conditions for maitake mushrooms. Optimizing growth conditions for maitake mushrooms builds on creating a balanced environment that supports vigorous mycelial colonization and robust fruiting. This involves using a nutrient-rich hardwood-based substrate or well-supplemented sawdust blend, maintaining incubation temperatures and then transitioning to slightly cooler conditions during fruiting. High humidity combined with proper ventilation to manage carbon dioxide levels and moderate indirect light are crucial to encourage the formation of distinct clustered fruiting bodies. By fine-tuning these parameters, growers can consistently produce high-quality maitake mushrooms with optimal flavor and medicinal properties. Let's discuss in detail the optimum conditions required for the growth of maitake mushrooms as follows. Let's have an overview of maitake mushrooms. First, we talk about its biology and natural habitat. Gryphola frondosa, commonly known as maitake or hen of the woods, naturally grows at the base of the hardwood trees, oak, maple, and elm in temperate forests. Its clustered, feathery fruiting bodies are prized for their rich flavor and reported health benefits. Mimicking the conditions found on decaying hardwood in nature is essential for robust mycelial growth and eventual fruiting. Let's now talk about its substrate selection and preparation. First, what are the substrate options available? We have hardwood logs. Traditionally, maitake is cultivated on freshly cut hardwood logs. Logs of an oak with 40 to 50% moisture content provide a slow release nutrient source and support extended fruiting cycles. Logs can produce flushes over several years. Now let's talk about the sawdust based blocks. Commercial and indoor growers often use a mixture of hardwood sawdust, preferably oak, supplemented with bran or soybean hulls. A common ratio is around 65 to 80% sawdust with 20 to 35% supplement. This blend must be adjusted to achieve an optimal moisture content, typically around 57 to 65%. A squeeze test should release a few drops of water. Let's now talk about its sterilization or pasteurization. Logs. Some growers pre-treat logs by steaming, boiling or pressure cooking to reduce contaminant load, though full sterilization is not always performed because the natural microflora can help outcompete pathogens. Now let's talk about the sawdust substrates. These should be sterilized via autoclaving around 121 degrees Celsius at 15 psi for 1 to 2 hours to ensure that competing microorganisms are minimized before inoculation. Let's now talk about the spawn selection and inoculation. First is the spawn types. We have plug spawn for logs. Plug spawn colonized dowels are inserted into pre-drilled holes in hardwood logs. This method is popular in traditional cultivation and helps ensure even colonization across the log surface. Let's now talk about the sawdust grain spawn for blocks. When using sawdust substrates, an inoculation rate of around 5 to 10% by weight is typically recommended to ensure a rapid and uniform mycelial colonization. Let's now talk about the inoculation techniques that we have. For logs, drill holes approximately 1.25 to 1.5 inches deep in a diamond or staggered pattern. Insert plug spawn into each hole and seal with food grade wax to maintain moisture and prevent contamination. For sawdust blocks, mix the cooled sterilized substrate with the spawn in a clean aseptic environment. Pack the mixture into autoclavable bags or blocks with breathable filters that allow gas exchange while retaining moisture. Dear students, let's now have the concluding remarks based on today's discussion. A successful specialty mushroom cultivation system depends on recreating the precise microenvironment that these fungi naturally require. By fine-tuning factors such as substrate composition, moisture levels, temperature, humidity, and gas exchange, growers can emulate the natural habitats of varieties like shiitake, maitake, and enoki mushrooms. Advanced monitoring tools ranging from simple hygrometers to IoT-enabled sensors and even artificial neural networks play a vital role in continuously managing these parameters. This level of precision not only maximizes yield and enhances fruiting quality, but also minimizes contamination and reduces production risks. In essence, a holistic approach that combines meticulous environmental control with sound substrate and spawn management transforms mushroom cultivation into a sustainable and high-yield operation. Such optimized systems not only support the culinary and nutritional demands of specialty mushrooms, but also contribute to food safety and, in some cases, even to broader sustainability goals. Ultimately, the key is to maintain a dynamic balance, adapting techniques and technologies to the specific needs of each mushroom species, thereby ensuring both the profitability and quality of the final harvest. Dear students, this concludes our today's topic. Hope you have learned and enjoyed it well. Thank you.